Hello everyone. Today we'll be doing a do-it-yourself experiment designed to teach you about fundamental frequencies and resonance as it relates to earthquake engineering.
The terms frequency and period must be defined to understand this experiment. Frequency is defined as the number of complete cycles in a second, measured in hertz or cycles per second. And period is defined as the amount of time it takes to complete one cycle, measured in seconds. When we talk about earthquakes and structures, we are concerned with the amount of time it takes for something to move back and forth, meaning that we define a period as the amount of time it takes for something to move in one direction and then move back to its original position.
For the experiment, you're going to need a cardboard box, something about this size works well, 3 pipe cleaners, 4 rubber bands, some extra cardboard, tape and scissors to cut and splice with, and a book for weight, as well as anything that's cylindrical shaped. These are going to act as rollers, and cans work very well.
Here we're placing the rollers inside of our box and the modeled ground surface on top of them, as well as 2 cardboard spacers to prevent the rollers from sliding out from under the ground surface. Next, we will secure the ground surface to the box with rubber bands and small pieces of cardboard to ensure the bands are taut. Structural engineers use shake tables to model the effects of earthquakes on structures. A structure subjected to an earthquake experiences cyclic movement that can be idealized to be at a certain frequency. The frequency that the ground moves is determined not only by the earthquake itself, but also by the soil it rests on. Additionally, every structure has one or more frequencies which the structure moves, which is referred to as the fundamental period, measured in time that it takes for the building to sway back and forth one time. This is significant to engineers because if the period of this ground's movement is similar to a structure's fundamental frequency, an effect called resonance will take place. Resonance leads to extreme movement of the structure, which generally leads to the structure failing. In this activity, we will observe how structures of varying heights may react to the earthquake we model.
So what we just made is a very simplified model of an earthquake. You can imagine that the top of this book is the ground, and everything on top of it is like a building that will move. So now we're going to build a model of a city. What you're going to want to do is start by a vertical face, and we're going to use pipe cleaners to model individual structures. Now if you notice, every structure has a fundamental frequency that it vibrates at. So this is a long structure that vibrates slowly. If we hold it here, it vibrates faster. To model 3 different heights of buildings, we're going to cut these to 3 different heights and then tape them here.
As you can see, we used equivalent weights modeled through the cardboard squares shown for each structure to keep all variables constant besides structure height. This is done in order to effectively model fundamental frequency.
So now we've constructed our model of an earthquake and our model of 3 different buildings. You'll notice that I put little pieces of cardboard on this. You can change how high up on the pipe cleaner this is to adjust the frequency that the modeled structure vibrates at. So if you move it higher, it'll take longer to vibrate, and if you move it lower, it'll move quicker. What you want to try to do is make it so that one of yours, preferably the center one, moves at about the same speed that your model earthquake moves. Now is a good time to use this equation to calculate the period of each of your structures, ensuring that your center structure matches that or is very close to that of your earthquake. Alright, so we've used our stopwatch to calculate the period of each of these structures. This long one, we calculated 1 second. This one is 0.6 seconds, and that one is about 0.28 seconds. And the fundamental period of our modeled earthquake is about 0.58 seconds.
As you see here, the base of all the pipe cleaners must move with the earthquake, but the structure with a period of 0.6 seconds is moving much more. This effect is called resonance and is happening because the ground motion and fundamental frequency of the structure are very close. If this were a real structure, it would be dealing with significantly higher forces than the other structures. Remember that the period of the ground motion is determined mostly by the type of soil that the structure rests on. For this reason, engineers must predict the frequency of the soil based on soil properties and then design a structure that will either not resonate with the earthquake or that will be able to resist very large forces in the case that it does resonate.